I'm going to go ahead and review properties of parabolas. So there's a couple new vocabulary words here, focus and directrix. The focus is located inside the curve of the parabola, and the directrix is a line that is on the outside of the parabola. And the distance between the vertex point and the focus is called P, which is also the same distance as the vertex to the directrix. That's also called P. So I'm going to go ahead and do a couple of these problems just to help re-explain these two vocabulary words. So given this first example, the focus is given to us as -6,4, and the directrix is x equals 2. So the first thing I'm going to do is go ahead and graph both of these on my graph. 2, 3, 4. So there's my focus. I'm going to put an F there and label it focus so I don't get it mixed up with the vertex later. And then x equals 2 is my directrix. Now, to find the vertex is going to be found halfway between the focus and the directrix, because that distance of P up here in our picture is the same distance each direction. So all I need to do is determine how far away the focus is from the directrix and then find the middle of that. So it looks like it's 8 units, so halfway would be 4. 1, 2, 3, 4. So there is the vertex point. So that ordered pair is -2, 1, 2, 3, 4. And that's my HK. Now, because the focal point is always on the inside of the curve of the parabola, I know that the parabola needs to open to the left from that vertex. To find the p-value then is that distance between the focus and the vertex. So that's 4 units. Now I need to solve to find the a value, and so we're going to use the formula up here from the top. So I'm going to do my calculation. So a equals 1 over 4 times p. And I'll go ahead and actually write that in here first. That's a p. And now let me go ahead and put the number in there. So that's 1 over 4 times 4, which is 1 over 16. So that's my a value. So now I can use that a value to write my equation. Now I know that this graph opens to the left. So this is going to be an x equals equation. I also know, because it opens to the left, that the a value needs to be negative. So that a left piece there is telling me that I need to have a negative on my a value. So it's -1 over 16 times y minus, and now I'm going to put the k in there. So here's hk. K is 4, close squared, and then minus 2 for my h. And then the last thing I need to do is to go ahead and finish graphing this parabola. So I'm going to go ahead and make a t-chart using my parent function. And when I do this, I'm just using the parent function y equals x squared. 0, 1, 2, 3, 4, 0, 1, 4, 9, and 16. And I'm going to go ahead and multiply each of these by the a value, which is 1/16. And so 1 times 1/16 is still 1/16. 4 over 16 is 1/4. 9 over 16 reduces, what is that, 3/4. And then 16 divided by 16 is 1. So this is a really flat, wide parabola. Now the way I graph this then is to turn my paper so that the vertex and then the focal point it's opening up. And then I use my counting pattern from there, just like if I was graphing a normal y equals equation. So I go over 1 and up a 16. So we're going to barely see any changes here at first with this graph. 1/4. It's just barely, it barely looks like it's changing at all. And if I can get over out 4, it's actually up 1, which is going to be way up there. And then you should make it look curved. Don't make it look like a V as you're doing this. Okay. And there's my parabola. We have the equation, we have the vertex, and the direction. Okay, the second example I'm going to do is on the back of this. When I'm given an equation, how do I find from the equation and find the vertex and the focus and the directrix? Let me do number 4. There we go. Okay, so this is an x equals equation. We'll continue with our horizontals. So now these are flipped around. So k comes first, h here. My vertex is still hk. So the vertex is going to be -1, comma, -2 because the insetters lie on those parentheses. I'm going to go ahead and graph the vertex, -1, -2. I know this graph is going to open to the right because the a value is 1/8, and it's positive, so this graph opens right. Okay, now I'm going to use that a value to calculate the p value so I can get more information about where the focus and the directrix are located. So p equals 1/4a. So it's 1/4 times 1/8. So 4 times 1/8 is 1/2. So it's 1 divided by 1/2. And when you multiply by the reciprocal, and you take the inverse of this, you end up with p equals 2. Or if you're using a calculator, just type in 1 divided by 0.5, and you should get 2. So this p is the distance between the vertex and the directrix, and then between the vertex and the focus. So when I'm looking at this, though, I need to make sure I'm paying attention to how this graph is opening. So from the vertex point, since the parabola opens to the right, that means that 2 units to the right is going to be my focus. And then if I go 2 units to the left, that's going to give me the directrix. So the equation for the directrix then is going to be x equals -3. The focus, which isn't on here for some reason, focus, the ordered pair is going to be +1, -2. The axis of symmetry is going to be perpendicular to the directrix going through the vertex and the focus. And there's my vertex there. This is the axis. So that equation is y equals -2. Now, to finish graphing the parabola, I need to make a table. So let's go back to our parent function, x, y, 0, 1, 2, 3, 4, 0, 1, 4, 9, and 16. And then we're going to multiply each of those by my a value, which is 1/8. So we do that multiplication, so I get a 1/8. 4 times 1/8 is 1/2. I have 9/8. And then 16 times 1/8 is 2. So now I can finish graphing. Again, what I'm going to go ahead and do is rotate my paper so that the focus is going up. So the graph is opening up, the parabola is opening up. And I'm going to go from the vertex and go over 1, up an 8. 4 is 1/2, or, oh, excuse me, over 2 and up a 1/2. And I'm going to go to 16. When I go over 4, it's up 2. So from the vertex point, 1, 4, 1, 2. Okay, so there's our parabola there. All those pieces graphed. Okay, and then I want to do one more problem with you that's not on the notes. So what I'd like for you to do is go ahead and turn your packet to the back page, the outside cover, and we have the back of it. There's the front. So then the back has some extra grids there. So we'll go ahead and use those grids. I'm going to go ahead and give you this particular quadratic that we'll use as our sample problem. And what we want to go ahead and do is to write the equation of this parabola and then also calculate the directrix and the focus for the parabola. So this is kind of a good review for all the different things we need here. So you might want to pause the video so you can copy this information down. So now that you have this copied down, let's go ahead and find the different pieces. So let's start with the vertex of the parabola. 2, 3, 4, 1, 2. So -4, 2. Direction. So our direction is to the right. This is telling me that I have a positive A value. The axis of symmetry cuts through the vertex. And these parabolas are always going to be symmetrical. So the axis of symmetry is y equals 2. Now I'm going to begin to write this equation and calculate the A value. So to do this, I'm going to go ahead and start with the basic vertex form of my equation. So I have it's going to be x. X equals A times y minus, then we're going to put the hk in, but k goes first this time, so 2 goes in there. Close squared. Make sure that you have the squared on the outside. And then -4. Okay, now what we're going to do is we're going to substitute another point from this graph into the xy for this graph here. So I'm going to choose, let's go ahead and choose this one here, -3, 0. So I'm going to substitute -3, 0 in as my xy point, as my extra. And that comes off the graph. So -3 equals A times 0 minus 2, close squared, -4. I'm going to go ahead and add 4 to both sides. When I do that, I get 1 equals, and then parenthesis, A first, then parenthesis, and I'm going to go ahead and simplify inside. So 0 minus 2 is -2 and then squared. But -2 squared, even though it's negative, negative times negative is a positive, so this actually becomes 4a, or a times 4 equals 1. And then to get a by itself, I'm going to divide by 4. So a equals 1/4. Does it make sense that a is a positive number? Yes, because we said that the graph's going to open to the right, so a should be a positive number. So now we can go back and actually write the entire equation. So we're going to take our equation from there. So I have x equals, we're going to substitute the a value in that we just found. So that's a 1/4 times y minus 2 closed squared minus 4. So there's the equation of that graph. Okay, the last thing I'm going to go ahead and do now is calculate the p-value and find the directrix and the focus. So I already have my a value, which is what I need to find the p-value. So p equals 1/4a. We know what a is, so 4 times 1/4. 4 times 1/4 is 1, so 1/1 equals 1. So that represents the distance from the vertex to the focus on the inside of the curve, and then the distance from the vertex to the directrix on the outside of the curve. So I'm going to come over here, and I'm going to count 1 unit inside, and that's going to give me my focal point, the focus. And then I'm going to count 1 unit outside, and that's going to give me the directrix. So the equation for the directrix then, 1, 2, 3, 4, 5, x equals -5. And the equation for the focus, with it being inside, is not an equation, it's an ordered pair. And it is 1, 2, 3, -3, comma, 1, 2, +2. Okay, so that has all the pieces that you need. Understanding how to calculate the a value from a graph, understanding how to write a horizontal equation, understanding how to calculate the p-value, and to find the the directrix and the focus from that information. Hope this helps you out. Please study for your test tomorrow.